In this video, we are going to learn about the determinant of any matrix, right? How we can find the determinant of matrix. For example, if we have to see the order of matrix. If the order of matrix is, if it is a matrix, right, with 1 cross 1, okay, so it will have only one element, that is A, 1, 1, okay. So what is the determinant of this matrix? It would be A, 1, 1. It is a determinant of matrix. Okay. Second, if we have matrix of order 2 cross 2, okay. Okay. For order 2 cross 2, we can write it as, right, what is order 2 cross 2? It will be A11, A12, A21, A22, right? So how will we find the determinant of matrix? We'll just do cross multiplication. Okay. It would be A11 cross A22, okay, and we'll put negative A12 A21, right? So this is the determinant. How we represent the determinant? It is written as determinant, okay? So in A, in between these two standing lines, it is the determinant. Okay, in mathematics this symbol is also known as modulus, but for matrix it is determinant. Let's take an example. If we have matrix 1, 2, 3 and 4, how we are going to find the determinant, right? So determinant of matrix A will be given as 1 cross 4, right? Remember these arrows, okay? So it is 1 cross 4 minus 2 to 3, right? So it will give you 1, 4 minus 6. So the answer will be minus 2. So minus 2 will be the determinant of matrix A, right? For 2 cross 2. Okay. Now let us understand the determinant of matrix 3 cross 3, because we are going to find the determinant of matrix which are square matrix. Okay, we can find the determinant which are square matrix. Okay. Now for 3 cross 3, how we'll do the matrix? Let a matrix be A. Okay, we have A matrix, right? How we represent 3 cross 3? It is 1, 2, it's 1, 1, 1, 2 and 1, 3, A21, A22, A23, A31, A32 and A33, right? So it is a matrix. Now how we can find the determinant? For determinant we can do expansion in rows or we can do expansion in column, right? We can keep any one row or any one column as a constant, and then we can find the matrix of square matrix, which is this sub-square matrix within the matrix. Okay, so it will be much more convenient for you to understand if we take an example. Okay, you can remember any one method. So I'll be showing you a method which is expansion through row 1, because in exams you will be asked to find the determinant. Okay, you can use any method to find the determinant. So I'll be showing you the method which is expansion through row 1. Okay, so how you expand using row 1? For matrix A, if you want to find the determinant, we have to write it as A, 1, 1. Okay, this row is as constant. Now if we hide this row, okay, these are the matrix. Now this is the square matrix. this is a square matrix left. Okay, you can hide this row and you can find the determinant of this square matrix, right? So we take A11. For A11, wherever A11 is, okay, this is the row of A11 and this is the column of A11. So what you will do, you will hide this row and this column. So you are left with this. Now you can write it as A22, A23, A32, A33, right? So this. Now next what you can do is, you put here negative. Now you will take A12. Okay. For A12, I am representing it with green, okay, green color. If A12, this is the row and this is the column. Okay. So you are going to hide these two elements and the remaining will form your this, and this will form your square matrix. Okay. So it would be A21, A23, okay, A31, A33. So it's very simple. If you see the color here, this green color represents for the second square matrix. Okay, you have to hide all the rows and columns which contains A12. Okay, so this is the way to remember like what elements are to be kept here. Okay. Now for third one, okay, this is the last element. So this is row is the same for all three. This is going to be a column. So this will form your square matrix for the third element. Okay. So how you will write it as, okay, and the second most important thing is you have to keep here positive. Here you have to keep it negative. Okay, so it would be A13. Now what you will write? Elements in this yellow square. Okay, so it is A21, A22, A31, A32. Okay, and now you can solve it as a square determinant. Just cross multiply and you will get the answer. Okay, we'll understand this matrix using an example. Okay, so for your better understanding. Now let's take an example. Let's take an example. Let A be a matrix 1, 2, 3, 4, 5 and 6, 7, 8 and 9. So this is your matrix. Now how you are going to find the determinant of this matrix? Okay. So it is A determinant. So very first thing is, we know this is the constant row. So the very first element of this is 1, right? Now forget this row and this column. You have to think about the other 4 elements, right? Because this row consists 1 and this also contains 1. So you have to eliminate these 2 and you have to keep these 4 elements, right? So you will be writing it as 5, 6, 8 and 9, right? It would be minus 2, right? We will take the second. For this, you forget this column and this row, right? So what are the remaining elements? 4, 6, 7 and 9. Okay, you will keep your plus 3, right? So this is your last. So this is the row and this is the column, right? So only this and this is left. So you will write it as 4, 5, 7 and 8, right? Now you will just find the determinant of these two, right? arrows downwards. So it would be 1, and then you'll write here as 5 into 9 minus 6 into 8, right? Minus 2, 4 into 9 minus 6 into 7 plus 3, 4 into 8 plus 5 cross 7, right? Now you can write it as 1, 1 minus 3 minus 2 minus 6 plus 3 minus 3, right? So you will get the answer as 0. Okay, so this is your basic, it's your basic mathematical calculation, and you will get the determinant as 0. Okay, so this is the process of finding any determinant of a matrix. Now let us move forward and understand the application of these metrics. Okay, where you can use these determinant of matrix, and how we can use determinant of matrix to find the inverse of matrix. Okay, and how these are used to solve any linear equations. In this unit, in this chapter, basically there are two applications of determinants. The first is to find the area of triangle, and the second one is the solutions of any linear equations. Okay. So these are the two applications of determinants that we are going to study now, because in mathematics every term is used to solve the problems. Okay, so these are the two problems: how to find the area of triangle and how to form the solution of any linear equations. Okay, so these two can be easily resolved using the determinant of matrix. Okay, so let's understand the area of triangle. If you have a triangle with vertices, vertices A1, A2, this is a let's this be a triangle. So this is A1, this is B2, this is A1, B1, sorry, it's A2, B2, and this is A3 and B3. So these are the vertices of the triangle. Now how you are going to form the area of this triangle, right? So now you can write it as area of triangle is half, right? You have to find the determinant of matrix A1, A2 and A3. Here you will write B1, B2 and B3, and the last column will be 1, 1, 1. If you will find the determinant of this matrix and you will multiply it with half, you will get the area of the triangle. Okay. Now let us understand the minor and the cofactor, right? What is a minor and what is a cofactor? Okay. So very first thing is the minor. What is a minor? For example, I represent minor with I. Okay. First we'll understand the mathematical equation, right? What is minor, what is cofactor, then we'll understand it with an example. Okay. If you want to find the minor ij, then you have to eliminate, right? What you have to do is you have to eliminate the row I and the column j, and you have to keep the remaining one. Okay, you have to find the determinant. Okay, you have to find the determinant of matrix, basically square matrix left after eliminating ith row and the jth column. Okay. First understand this mathematical equation and the mathematical definition of minor. For better understanding, we'll see it through some examples. Now similarly we have cofactor. Okay, if we have cofactor A ij, right? So this cofactor can be represented as -1 I plus j, right, into m I j, right? So this is your second cofactor. This is cofactor. Right? Now we'll move forward, okay, and we'll understand this minor and cofactor with some example. Now let's take a matrix A. Let's take a matrix A as 2 minus 3 5, okay, 6 0 4 1 5 and minus 7. This is your matrix. Now we'll first find the minors and the cofactors of this matrix. So to find the cofactors, we must understand what are minors. Okay. So for example, let's take minor 1 2. Okay. We'll find minor 1 2. Minor 1 2, minor 2 1, okay, and minor 3 1. Okay, you have to find these minors and you have to find the cofactors. Okay, cofactor 1 2, 2 1 and a 3. Okay, this we are finding 3 minors and 3 cofactors. Okay, to understand what are minors and cofactor. You can find minor and cofactor for each row and column, but here I am specifying it with these 3, right? So first we have minor 1 2. Okay, so you have to eliminate row 1. You have to eliminate this row 1. And second is column 2, you have to eliminate this column 2. Okay, so this and this you have to eliminate, right? So you will get it as 6 4 1 and minus 7. So you will get, and you will find the determinant, right? So it is 6 7, so it will be 42 minus 42 minus 4. So you'll get the answer as minus 46, right? Similarly, let's take the second M21. M2 1. So it would be second row. So this is the second row. And first column. So this is your first column. You have to eliminate these two and you have to write the remaining. So the remaining will be minus 3, okay, and 5 and 5 and minus 7. 5 and minus 7, right? So you get the answer as 21 and minus 25, right? Minus 4 is the answer. Now let's take for n 3 1. Okay, so this is your third row. So this is your third row and your first column. So this is your first column. So these remaining will be minus 3, 5, 0 and 4, right? You will get it as minus 12 and minus 0 and you get the answer as minus 12. So these are the three minors, right? Now we'll have to find the cofactors. For cofactor, we know that ij is equals to minus 1 I plus j into the minor. Okay, you have to multiply it with the minor. So for this, a1 2 is given as minus 1 plus 2. Okay, and minus 46, right? So it would be minus 1 into minus 46. So you will get it as 46 as the cofactor. Similarly for a 2 1, you can write it as minus 1 2 plus 1, right, into minus 4. Okay, similarly you will get the answer as 4, right? Now last is a 3 1, right? For a31 minus 1, 3 plus 1 into minus 12, right? So it would be positive 1 into 12. So you get the answer as it's minus 12. So you get the answer as minus 12. So these are your three minors and the cofactors. You can find all the minors and cofactor using this method. Now where is this minor and cofactor used? From minor you can find the cofactor, and from the cofactor you can find the adjoint and the inverse of matrix. Before moving forward, okay, let's understand one cycle because it will help you in exams to remember what is adjoint, what is a minor, cofactors and all. Okay. So let's first understand the adjoint of matrix. Okay, what is adjoint of matrix? Basically, it is adjoint A of matrix A is represented as transpose of cofactor matrix of A, right? What is this? Transpose of, right, A11. This is cofactors, right? We have learned how to find the cofactors. So these are the cofactors here. 21, A22, A23, A31, A32 and A33. Okay, so this is the basic definition of adjoint of A. Now if we want to find the inverse of matrix, okay, like what is the inverse of matrix? inverse of matrix. We have also studied inverse of matrix in previous video, right? So this is another method to find inverse of matrix, and it is much more simpler. It says A inverse is equals to 1 upon determinant of A, right, and the adjoint of A. You have to find the determinant of A matrix, and you have to find the adjoint of A matrix. Okay. If you know these two, you can easily find the inverse of matrix A. Okay. Now let's understand one cycle, right, so that you can never forget how to find minor cofactors and all. Okay. So very first thing is we have a determinant, a matrix A, right? If we find from matrix A, okay, this is determinant of matrix right? From determinant of matrix we can find minors. From minors we can find the cofactors. If we know the cofactors, right, from the transpose of cofactors, you can find adjoint, right? And if you know the adjoint and determinant of matrix, from these two you can find inverse of matrix. Okay. So from minor you can move to cofactor, from cofactor you can move to adjoint, and from adjoint you can go to the inverse of matrix. So this is a conclusion, like if you want to find the inverse, what all you must know, and to find the cofactor you must know minors. So this is a basic cycle of matrix. Now how to find the solution of equations using matrix. Okay. So we know the equations. Let it be a1 into x plus b1 into y, right, plus c1 into z is equals to d1. Second be a2x plus b2y plus c2z is equals to d2. Similarly, a3x plus b3y plus c3z is equal to d3. Okay. Now we can find what? A matrix as coefficients of the variables a1, b1, c1, right, a2, b2, c2, a3, d3 and c3, right, and x can be written as all the variables x, y and z. Okay. And b can be represented as constants. So these are the coefficients, these are the variables, these are the constants, right? Now how you can find this solution? Okay, so the solution is basically the value of x, y and z, right? So how you can find these solutions? You will find this solution by x the solutions are equals to inverse of A into B, right? Because here you can see it is written as A x is equal to B. So this is the basic format of any equation. This is A, x and B in the terms of matrix. In terms of matrix, this is the equation. This is the equation in terms of matrix. If you want to find the x, it would be A inverse B. Okay, so this is how you are going to find the solution of any equations. Okay, so there are some conditions, right, which will make you understand like how many solutions are possible. It will have a unique solution, it will have two solutions, or there exists no solution. So there are certain conditions that you have to keep in mind, right? So the very first condition says if determinant of matrix A is not equals to 0. Okay, and to find the inverse, we know we have to find the adjoint. If the determinant is not equals to 0, okay, so there will exist a unique equation, unique solution. There will be a unique solution if it is not equals to 0. Second says if the determinant of matrix A is equal to 0, there are two possibilities. Okay. Then you have to find the adjoint of A cross B, right? Adjoint of A you have to find because you have to find the inverse for solutions. So if adjoint of A into B is not equals to 0, okay, it is not equals to 0, then it will have no solution. There will be no solution. If determinant is 0 and adjoint of A cross B is also equals to 0, both are 0, both 0, okay, may or may not be consistent. Solutions may be consistent or may not be consistent. If both are equals to 0, so it may be consistent or it may not be consistent. Okay, so this was the whole determinant topic which we have understood now, like what is a determinant of matrix, what is minors, cofactors. So this is the complete introduction of your chapter determinant. Thank you for watching.